Here we are, fellow geometry students. We are into some circular geometry today. Our 21st lesson of the year. Does not seem like it's 21st lesson, does it? Wow. Well, we're humming along. We've only got a few lessons left to go and then some review before the final exam. Let's start talking about today's daily agenda. Well, we got our typical weekly plan this week, 2 lessons and a quiz. We're going to start off with some review questions. And then we're going to get into arcs and angles in a circle. We're going to stop at that particular point in time. We're not going to do segment lengths in a circle. We're going to save that for the next lesson because I felt to include that in this lesson would make this lesson too long and the next lesson too short. So we'll slide it over into the next session and have it covered at that time. Let's begin with some review questions. You know the drill, stop and start. Okay, so they tell us that EC is congruent to FA. And then they tell us that EC is parallel also to FA. And as soon as I read about parallel, I think about a few different things, but near or at the top of the list is alternate interior angles and corresponding angles. In this particular problem, what I see is alternate interior angles. With angle C up here, here's my Z, my backward Z in this case. Oh no, my regular Z. So here's my Z, and the tucks of the corners there, those interior angles, alternate interior angles, those are our congruent because alternate interior angles of those parallel lines that they mentioned are congruent. And last but not least, I hope you can see the vertical angles there. And that gives me, if you look, the side is not in between the two angles. So that gives me AAS is congruent to AAS. Next up, a little similar triangle review from last week's work. So in this particular diagram, angle W corresponds to angle D. You can see that either just by looking at the triangle, but sometimes that's a little tricky. You can see it in the way the triangles are labeled. When it says triangle WXY is similar to triangle DCE. So the W and the D pair up, therefore 60 degrees. If you have any questions on this one, keep in mind about the WXY and the EGF. Okay, so the first thing they ask you for is angle F, and we notice that angle F pairs up with angle Y. So if angle Y is 88, angle F is 88. But now what about angle X? Well, you'll notice that X pairs up with G. So therefore, if angle G is 60, angle X is 60. Well, this guy is my little is to big, as little is to big problem of the day. We might have 2 of them, but here's one of them for sure. So little is to big as little is too big. So the side of the little triangle is to the corresponding side of the big triangle. So 6 and 7 is also in the little triangle, and 30 is in the big triangle, and they want AC. So we're going to call AC, that side has length X, it's the unknown. Cross multiply 6x, right? Because cross multiplying 6 times X is 6x, 30 times 7 is 210, dividing by 6, X is 35. I didn't write the divide by 6 step here, but I figure you knew what to do. Okay, another little is to big guy. Go ahead. Okay, so we have similar triangles here. A little is too big as a little is too big. Hey! I'm crooning my voice on that one. Wait till I get to the rap version. Matter of fact, there's one more left. I'll do the rap version on that one for you because I know it's by popular demand. So, side of the little triangle 1, that matches up with 10, and it wants AB. And what I could tell by this, I just look at it and I sense that AB pairs up with YZ, but let me see here. AB is the first 2 letters, YZ is the first 2. That confirms it. So 1 corresponds or pairs up with 10. 2 pairs up with X. Cross multiplying, 1 times X is x. 2 times 10 is 20. So x is equal to 20. A little easy on that one. And now, a little is too big as a little is too big. Little is too big as you little is too big. Little is too big as a little is too big. Yo, word up. There's my little triangle. There's my big triangle. The side of the little triangle, 230 and 120 are the two sides of the little triangle. Now the big triangle in blue down here at the bottom, that's 230 plus 85, which is 315. X is the missing side here, BC. Cross multiplying, 230x equals 37,800. Divide by 230, and I get x equals, rounded off, as they said in the problem, 164. Okay. All right, so 0.52 is rotated counterclockwise 90 degrees about the origin. Its image will be. Well, remember with rotations, this is one where I suggested that remembering the rule is actually a good thing rather than understanding it. Not always easy to see. So xy becomes negative yz. So 5,2 becomes negative 2,5. And that is choice 1. Go ahead. Do them both. Okay, so if AB is parallel to CD, which of the following must be true? Well, there's your AB parallel to CD, and there are your alternate interior angles. So angle 1 must be congruent to angle 2. Next, given 3 distinct quadrilaterals, a square, a rectangle, and a rhombus, which quadrilaterals must have perpendicular diagonals? Well, a rhombus has perpendicular diagonals. Again, these are all on those properties of parallelogram sheets we gave you. The rectangle does not, however. Think about it. If you have like a really long, thin rectangle, would those diagonals be perpendicular? I don't think so. Now, a square has perpendicular diagonals also. And that kind of makes sense because a square is a particular kind of rhombus. So that makes sense. And obviously choice 4, because the rectangle's there, that's not going to work. So choice 3, the rhombus and the square. Okay. So we mentioned it a couple of times already that we have alternate interior angles here. So I'll make them equal. 4x equals x plus 15. Subtracting the x, 3x is equal to 15. X is equal to 5 when we divide by the 3. Go ahead. This guy is that the measure of an exterior angle is equal to the sum of the two remote interior angles. So this 80 in here and this 5x minus 7 have to add up to the 14x plus 1. So 80 plus 5x minus 7 is equal to 14x plus 1. Subtracting 5x, 73 is 9x plus 1. Subtracting the 1, 72 is 9x. Dividing by 9, x is 8. All right, next up. Rhombus graphed on the set of axes below. Which transformation would carry the rhombus onto itself? Okay, so the one that will work is if I reflect over the line x equals 0. That's the line x equals 0. It will work because it's perfectly matched up on both sides. Choice 3 does not work because that's your horizontal line. And if I flip it, I would get a triangle that goes down here. Or I should say a quadrilateral. 1/2 x plus 1. It's right through here, and it wouldn't be the same on both sides. This point here would end up here. And the 180 degree counterclockwise rotation would just similar to going over x equals 0, you would end up down in here. So that's not going to be it either. Okay. That, folks, it's a nice review right there. It's a lot of the topics we've been going over lately, and if you could get them all right, you're certainly in excellent shape.